Hi, all of you beautiful sixth grade Elms mathematicians. I miss you dearly, and I can't wait to get back with you. I'm hope everything is going okay. I hope you're working hard, and I can't wait to see you when all this sort of shutdown is over here. But in the time being, I'm going to try to give you some videos and some other kinds of resources to help you kind of make sense of some of the things that we would be doing during this time. And then when we come back, we're going to try to clean them up. So with this one, we're going to focus on order of operations and about evaluating expressions using the order of operations. The word evaluate really just means answer. It means simplify your answer to one value. Now that is can sometimes be a little bit tricky in the sense that what if you've got an expression that has multiple things going on? We have to be able to evaluate that using a certain order of operations. So before we dig into that, I just wanted to let you know at the end of this video, you're going to be posting in a discussion the answers to 3 questions. You can feel free to use the note catcher that I provided or some scrap paper to capture your thinking for each question, but I wanted to give you the questions ahead of time so you could be thinking about it. Only a sentence or two for each question is fine. And the first question is, what does it mean to use the order of operations? Second, why does multiplication and division need to be answered before addition and subtraction? If you were to ask your parents, why do I have to do multiplication before evaluating addition? 98% of your parents would say, well, PEMDAS. And if you never heard of what PEMDAS is kind of an acronym, which is a placeholder for how you remember the order of operations, but really it's a rule. There's no real reason in PEMDAS other than that somebody told you to follow this order and you believe them, which is totally fine. But I'm going to try to unpack why that is true today. So that's one of the things of what I really want you to listen for. Why is it true that multiplication and division come before addition and subtraction? And then lastly, how should you show your work to make sure that you do not make small errors while solving these problems? Something to just also think about as we answer. So to kind of set us up, let's look at these 2 problems. Notice they're the same problem, and I've got 2 operations, addition and multiplication. I could solve this problem and say 3 plus 4, which is 7, and when I multiply it by 5, I get 35. But I also could say, well, if I did 4 times 5 first and got 20, then when I add 3, I get 23. Now, here's the thing. They're the same expressions, and that answer is absolutely not the same. And that is because, and that tells you right away that you can't just decide which operation to do first, that there is a certain order. And so sometimes people remember it with this acronym that I mentioned before called PEMDAS. Now, PEMDAS is a fine way to remember, but there are some problems with it. If you are somebody who has used this before, I just kind of want to talk about it. First of all, this stands for parentheses, exponents, multiplication, division, and addition and subtraction. The first thing is as I already mentioned, is there's no reason why this is true. This is true about the order of operations, but why is not exactly true. And the other thing is that multiplication and division are actually equally they are actually sort of equally in order. So sometimes you might do division before multiplication, or sometimes you might do addition before subtraction. So sometimes people, when they're following this rule, they get that kind of mixed up in some of that order. And so I'm going to kind of give you something to think about as we build on this idea of evaluating expressions using the order of operations. With that in mind, sorry about that. With that in mind, let's kind of talk about it. So if you get to this sort of next slide here, this is what I'm calling the triangle of power through grouping. Now, a lot of you probably remembered that the first things that you ever learned to do in math, besides identify numbers, was add and subtract. And that's because those are kind of the simplest forms of operations. Being able to say 3 plus 5 is 8 is combining 2 different things together to get 8, or taking 5 minus 3 to make that 2. Now, those are equally as powerful. So if you've got something like subtraction and addition, you have to go from left to right in the expression in order to because there's not one that goes first. So you just have to move left to right in the expression, which I'm going to model when we get down here. The next most powerful operation is multiplication and division. Now you might ask, well, why is it that I have to do multiplication and division before addition and subtraction? Well, if you think about multiplication, multiplication really is repeated addition. And because of that, when I think about this as groupings, I have to kind of break down that repeated addition before I get to simple addition. And that idea of being able to break that down is part of what it's really like I have to attack the thing that is the strongest group to get together first. So if I was to go back to this example and look at this problem here, I've got 3 plus 4 times 5, but this 4 times 5 really means 4 groups of 5. In other words, 5 plus 5 plus 5 plus 5. And in order to solve this, I've got to be able to do 5 plus 5 plus 5 plus 5 plus 3. And if I was to do 3 plus 4, I'm kind of breaking up that grouping in a way that is not actually what this problem is saying. Which is why if you were to go and solve this problem, that's why this one is actually not right. And I have to do it this way, because I have to tackle this 4 times 5, or this repeated addition, before I do basic addition in order to solve this problem correctly. So when I look at these examples, that's kind of that idea, is that I have to tackle this repeated addition and repeated subtraction, which is actually division, first to be able to get to addition and subtraction. But just like with addition and subtraction, I have to move left to right. So if I've got division, something on the left-hand side, like you can see down here, I've actually got to do the division first instead of the multiplication, because they're equally as strong. They're sort of grouped the same. They're the same kind of level of power of the grouping. And then lastly, it leaves us with this top part, which is exponents. Now, if you remember exponents from one of the last things that we did before we left, exponents is really this idea of taking like 5 to the 3rd power is really like saying 5 times 5 times 5. That is not the same as 5 times 3. That's regular multiplication. This is actually repeated multiplication or division, which is actually why it's the the strongest operation that we've gotten to so far, is because exponents are repeated multiplication instead of basic multiplication, where addition is multiplication is repeated addition instead of basic addition. So this idea is that I have to evaluate the things that are the strongest grouped together first before I get to the next level of the triangle, which is what we kind of call following the order of operations. There is one symbol I want to talk about first, and that is if you see a symbol called the parentheses, or even like sometimes we see like brackets of grouping, some kind of grouping like that, that is actually a specific symbol that says do this first. That's like I'm saying, I don't want you to follow normal order of operations. I want you to do this first and then follow the order of operations. So you're going to see some examples where there's some parentheses thrown in, and all that means is you got to do what's in the parentheses first. Everything else, you follow the normal order of operations. So when we get to this next part down here, I'm going to kind of model this example here first. We can do this kind of together. And then I'm going to want you to write this problem down on a piece of scrap paper and try to solve it first. Now, I'm going to kind of pause. What I would encourage you to do is pause the video before getting into that problem, and then so you have a chance to kind of think about it first. I'm not going to do that, so make sure that you pause the video before you start talking about this. And then I'm going to kind of pull this down and show you the solution and see if you ended up getting it right. And then if you didn't, make your revisions. And if you need to rewatch the video or try this again, of course, you always can. You can always replay it. So I'm going to kind of model this order of operations with this first one here. Notice that I've got some things. I've got division, subtraction, addition, multiplication. I do not have any exponents or parentheses. So I'm going to jump to this level of my triangle. In the middle of the triangle, I have to do multiplication, division, but I have to start with whatever one is on the left. And you'll notice in this example, this is where sometimes people make a mistake here. I've got to start with the division first, because I've got division and multiplication, but the division is the one that's on the left, which is what I have to tackle first. And remember, with division, ordered really does matter. So if I have an example where I'm doing multiplication first instead of division, I could end up getting something that is not accurate. So what I'm going to do to make sure that I don't make any mistakes is I'm just going to underline what I'm going to evaluate, 10 divided by 2, 20 divided by 2, which is 10. And then I'm going to rewrite everything else. Now I'm going to tell you, most people, when they do this, if they don't rewrite this, they tend to make very, very small mistakes. So this might speak to one of the questions I want you to think about, but you're always going to kind of rewrite and then go back to your triangle. So I'm done with division, so now I'm looking for multiplication. Notice I got multiplication here. 8 times 2 is 16. Now I'm going to rewrite everything else. So I got 10 minus 6 plus 16. Now, I'm done with this level of triangle, so now I'm going to go into addition and subtraction. So now I've got to look, and I've got addition and subtraction. I want to go left to right, so I'm going to do the one that's on the left first. 10 minus 6 is 4, and then when I add 10, I'm left with 14. Now notice, if I am really doing this by showing all my work correctly, what you should see is you should see this kind of upside down triangle, which is also what's kind of nice about using this triangle as the order of operations is it's like here I've got my top side triangle, but when I follow this order of operations, starting with the strongest to the least, I should be whittling this down, evaluating this down into one value. In this case, this expression is equal to 14. So at this time, I want you to pause the video, try to solve this one right here, and then when you think you've got it, play the video and see if you got it right. I'm going to wait a second. All right, so hopefully you've had a chance to solve this problem. So now let's kind of pull this down and see what we got. Notice that here I'm going to first, step one, I'm going to do the multiplication. 6 times 3, which is 18. Then I'm going to rewrite everything else. Now I've got addition times division. So now I'm going to do the division, which is the next part of that triangle. 8 divided by 2, which is 4. And then I'm going to rewrite everything else. So if I look at the next step here, I've got 5 plus 18 minus 4. So now I'm going to do the addition, 5 plus 18, which is 23. And then when I take away 4, I'm left with 19. So if you got that, really good job. If you didn't, we're going to kind of add the next layer here, and I want you to keep kind of moving with us here. So when we look at the next example here, I've got a little bit of one with exponents. Now notice the triangle, we always want to look for parentheses first because that's that symbol that says this has got to go first. But after that, I'm just going to follow my normal order of operations. Exponents is on top, so I'm going to start with the exponents. I got 3 squared, which 3 times 3 is 9. Don't fall into the trap of making that 3 times 2. 3 squared, or 3 to the second power, always means 3 times 3. Then I'm going to rewrite everything else over. Always make sure you rewrite everything so you don't make a mistake. Now I've got addition and multiplication. I'm going to do the multiplication first. 4 times 2 is 8. And then when I rewrite everything over, I've got 9 plus 8, which is 17. Notice the same kind of idea, except in this case, I'm using exponents first, and I end up getting this kind of triangle look just based on that same way. So just like I did before, I'm going to kind of slide this down so that you can see it here. I want you to try to tackle, sorry, it's a little hard to see here. I want you to try to tackle this expression. See if I can grab this and slide it out of the way here. I'll move it up here. I want you to try to tackle this expression, 4 squared, 4 to the second power, plus 2 to the fifth power, minus 10 times 2. And try to solve that one using the order of operations. So pause the video, give it a try, and then play it when you think you got it. All right, so here I'm going to kind of slide this back down here so that it doesn't kind of mess us up here. Let's see what we got here. So 4 squared is 16, and I actually did both exponents in that first step here. 2 to the fifth power is 32, and then I rewrote everything else, minus 10 times 2. Now when I look what's left over, I got addition, subtraction, multiplication. So I'm going to do 10 times 2 first, and I get 20. Then I've got addition and subtraction, so now I'm going to move left to right. So first 16 plus 32, which is 48, and then when I take away 20, I'm